Sorry guys, my video got cut off, so let's keep on working on this perimeter problem. So again, it's 30 plus 30 plus 24 plus 24, and you add together to get 108 feet. Okay, so that's how much edging material that they would need for the path. Alright. Alright, let me erase to get started on the next one. Alright. So the next one says, what is the circumference of a circle with a radius 4 feet in terms of pi? Okay, so what is the circumference of a circle with a radius of 4 feet? So radius is given 4 feet, and we're looking for circumference. So what I always like to start to do is I like to either draw a diagram or write down the formula that I'm going to use. Okay, and I get you both here. So I'm given a circle with a radius of 4 feet, and I want to know the circumference, which the circumference formula, if you're trying to find the circumference, it's pi times d, or 2 pi r, depending on what you like to use. So I need to know the diameter. Well, if my radius is 4, I'm going to double that to get my diameter is 8. So my formula becomes pi times 8. Now the directions did say leave your answer in terms of pi. That means you're going to leave pi as part of the answer. You're not going to actually multiply by 3.14, the approximation of pi. So the circumference is equal to 8 pi, and it's feet. I'm just going to go back and look. Feet. Okay, circumference is a linear measure just like the perimeter is, so it's just feet. It's not feet squared. Okay. The next problem says, what is the circumference with a circle with a diameter of 15 inches in terms of pi? Okay, so now I'm given the diameter, right? Is that what I was given? Yeah. So the next problem is 15 inches. And again, we're looking for circumference. So it's a similar problem. My example or my diagram here, my diameter this time is given as 15 inches. My formula is still the same, pi times diameter. The directions say to leave your answer in terms of pi. So it would be 15 pi inches. Okay, the number goes in front of the pi. Right, let me erase and we'll do an area problem. All right, so for the next problem, it says, what is the area of a circle? What is the area of a circle with diameter 16 inches in terms of pi? Okay, so again, start by writing the formula down, draw a diagram if you want. The area formula for a circle is pi r squared. Okay, so I need to know the radius. Well, in this case, I have the diameter is equal to 16. The radius is half of the diameter, so the radius is equal to 8 inches. Okay, so it's going to be pi and then 8 squared. So it's pi times 64. Remember, the number comes in front of the pi, so it's 64 pi. My units are inches. Since it's an area problem, my units are squared. And that would be your answer left in terms of pi. All right, let's find the area of an irregular shape. All right, so give me meters, 6 meters, and 18 meters. Okay, so this is going to use what we call the area addition postulate. You're going to want to break this figure up into rectangles and then add all the areas together. So you can either draw a bunch of vertical segments to get 3 long rectangles, or you could draw horizontal segments. Okay? To get the area of this piece, I'm going to need to know length and width. Here as well, I'm going to need to know length and width, and length and width. Okay, so we do have some measurements that we need to figure out. If I have 3 meters, 3 meters, and 3 meters, 3 meters, right, for this piece, 3 meters to match up with that one, and 3 meters to match with the bottom one, 3, 6, I know that this whole thing has a length of 9 meters. Okay, so I can at least figure out this rectangle, right? If I multiply the length and the width, 6 times 9, to get you an area of 54. Okay. Now I need to know the dimensions here. Well, I have 6, but I need to figure out this length here. Again, 3 meters and 3 meters, so this length here has to be 6. 6 and 6 gives you an area of 36. And then finally, you have to figure out this dimension here, right? I have 3 meters, but I have to figure this one out. Notice that this entire length is given as 18. I have 6 meters there. I have 6 meters there, so I can figure out the last and final piece is also 6 meters. This 6 plus 6 plus 6 gives you your 18. Now I have the length and the width for that last rectangle, the base and the height, to give you an area of 18. Okay, so to get your total area, you add the areas together, 18 plus 36 plus 54. Add them together to get an area of 108. And since this is an area problem, my units, which are meters, are squared. Okay. Just to get a quick look to see if there's anything else that I want to go over. We'll do one more. Okay, so I'm not going to do one of these problems, but I just want to show you in case it pops up in the homework. You might need to plot points in a coordinate plane, figure out the different lengths of the segments, and then plug into the area formula or add the pieces up together to get the perimeter. Okay, so just keep that in mind. I am going to sketch out one problem with you guys. Yeah, we'll do this one together quickly. Okay. So I'm going to draw a quadrilateral in a coordinate plane. So point A is at 2, 4. This is point A at 2, 4. Point B is at 2, negative 1. Point C is at negative 1, negative 5. Negative 1, negative 5. And point D is at negative 4, negative 1. Point D, negative 4, negative 1. Okay, so here's your four-sided figure, your quadrilateral. And we could ask a bunch of questions, you know, what's the area, what's the perimeter, and so on and so forth. All right, so we're first going to find the perimeter of quad A, B, C, D. In order to find the perimeter of quad A, B, C, D, I'm going to have to know all the different side lengths. So I'm going to have to know how long is AB, how long is BC, how long is CD, and how long is AD. Okay? So if it's possible, you could just count units in the coordinate grid. Okay, so for instance, since this is a vertical segment, one is right below or above the other, I can just count units, and you're going to get that that piece is 5 units long. So AB is fast and easy. That's 5 units long. But to get the distance from B to C might require a little bit of distance formula. Okay? And same with CD and then DA. So you might have 3 distance formula problems to do, which we do. So for BC, you want to find the difference between, B to C. You're going to use 2 and -1 as your x coordinates and -1 and -5 as your y coordinates. Remember, the formula is to take the difference, square them, right? It's all under a square root and add them together. So your formula would be 2 minus -1 squared plus -1 minus -5 squared. All right, and then for the distance between D and C, so you have to come over here and use these coordinates. Under the square root, you're going to have -4 minus -1 squared plus -1 minus -5 squared. And then finally, the distance from A to D. So now I'm using those coordinates. You're going to have the square root of -4 minus 2 squared plus -1 minus 4 squared. So take a minute if you want to pause and take a minute, make sure you understand the setup between all of those. And then when you simplify, okay, the first one's going to simplify to the square root of 25, which is going to be 5. The second one is also going to be the square root of 25, which is 5. And the last one is going to be the square root of 61, which is not a perfect square factor. So we're just going to leave it like that. Okay? So to find the perimeter, you have to add all the side lengths together. So your perimeter is going to be 5 plus 5 plus 5 plus the square root of 61. 5 plus 5 plus 5 is 15 plus the square root of 61. It's a perimeter problem, and I don't think units were given, so we'll just say units. If the direction said to round to the nearest 10th or 100th, then I would plug this into my calculator and get a decimal approximation. But since it didn't say to round, I want the exact answer, which that is the exact answer. Okay? All right, guys, so that is where we're going to end for today. Make sure you finish up notes, and I'll see you back here for the next lesson. Bye.